Okay, in this video we are going to cover some extra concepts that you will need for the homework. Some of the problems are going to ask about the amplitude, angle, phase, and period. So I have to explain what is that. Okay, now this only applies to free damping models. Okay, so you don't have a friction force. So the solution will be this one. The solution will be C1 cosine of beta t plus C2 sine of beta t. So there is no exponential, so right? So that will be the solutions. Okay, so what will happen here is that because there is no friction, then if I come here and I make a movement and then release it, so what is going to happen is going to do something like this. So it's going to be always oscillating without stopping because there is no friction force to stop. So it's going to do something like this. So the x-axis is actually the time, and the y-axis is the x. Well, the x is the distance around the equilibrium point. So that is going to do something like this, but in the time it's going to be just like this. Okay, so what is the amplitude? Well, the concept of amplitude is just from the minimum to the maximum. So that is the amplitude. And we are going to call that as just plain A, right? How are we going to calculate that? Well, I'm going to tell you that later. Now, amplitude, so this is the amplitude. Now, the next concept is just the angle phase. Now, the angle phase is because, as you can see here, this doesn't start in 0, right? And here is the pi, and so on. So it is a little bit shift, all right? It could be shift to the left or it could be shifted to the right. That will depend on the initial conditions. So if this is pulled down or if it is pulled up, so it's going to be on the right or on the left. Now what they are asking is about this angle phase. So this distance, and it is called phi. All right. So how many degrees it is shifted, not how many times it is shifted. Is just the phase. All right, the angle phase. All right. So that is concept number 2, and this is the amplitude, and the period is just the same as the amplitude, but here the concept is this. The period is how much is the time, how much time it requires to make one single cycle. So that is the period t. Alright, as you can see, it's just like the amplitude but in the time, right? So this is the period. Alright, so how are we going to calculate that? Okay, I just wanted to show you what is the concept here, the amplitude, period, and angle phase. And next I'm going to, I may need to erase this to tell you how to calculate each one of them. Alright? Okay, so again, the solution of this free damping movement in general is going to be x of t is going to be C1 cosine of beta t plus C2 sine of beta t, where beta is actually the square root of k over m, if I remember correctly. Okay, so what we need to calculate the amplitude, because the amplitude, if without the cosine, the amplitude will be this, all right? Or without the sine, this will be the amplitude. But what will happen if you happen to have both? So which is the amplitude? Is it C1 or C2, or is it a combination of them? Okay, what we have to do is to transform this into a single, instead of having two, the cosine and the sine, we are going to convert it to a single sine function. How are we going to do that? Okay, I'm going to use a formula. I'm going to write here the sine of A plus B is equal to the sine of A cosine of B plus the cosine of A sine of B. So I'm going to use that formula in here, because as you can see here, you have here the cosine, and then you have the sine, and here you have the sine. So it's very similar. So what we are going to propose is convert this into a single sine. But in order to do so, I have here the cosine, so I need this C1 to become the sine, and need this C2 to become the cosine, because you have here the cosine, and the sine, and the sine. Okay, so the B is actually beta t. So how are we going to transform C1 and C2 into the sine of A and the cosine of A? Okay, let's do this. Let's assume that you have a triangle here, okay? And here is your C1 and here is your C2, alright? Okay, of course, the hypotenusa is going to be C1 squared plus C2 squared. Alright, now I am interested on this angle face. Sorry, I spoiled the surprise. This is the angle face. Anyway, the cosine, okay, or maybe the sine of phi is actually the opposite over the hypotenusa. So it's going to be C1 over the square root of C1 squared plus C2 squared. So that is the sine of phi, this angle. Now the cosine of phi is equal to the C2, the adjacent over the hypotenusa, C2 over the square root of C1 squared plus C2 squared. Of course, we can write here the tangent. Tangent of phi is the opposite over the adjacent, C1 over C2. Okay, now, what I am interested is in this, because C1, I want to transform it into the sine, because here I have a sine, and I want this C2 to be converted to a cosine. Now, to be converted to a cosine, I need to be C1 over this hypotenusa and C2 over this hypotenusa. So that's what I'm going to do. We are going to do. So x of t, what I'm going to do is to divide by this and multiply at the same time. So the square root of C1 squared plus C2 squared times C1 over the square root of C1 squared plus C2 squared, and then the cosine of beta t plus C2 over the square root of C1 squared plus C2 squared, the sine of beta t. Okay, as you can see here, I haven't modified the solution, because if I make a multiplication, this times this, these are going to cancel, and you will keep the C1 cosine. And the same for this, C2 sine of beta t, if you do the multiplication. Now, but because of this, now this one I can replace it by the sine of phi. So cosine of t, the solution the square root of C1 squared plus C2 squared times here, this I'm going to replace it by the sine of phi cosine of beta t plus here this one is going to become the cosine of phi sine of beta t. Okay, now that I have sine and cosine, cosine and sine, I can actually use this formula. So that is going to be equal to the sine of A plus B. I mean, if this is A and this is B, A and B, alright? Not beta, but B. So the x of t is going to be x of t is equal to the square root of C1 squared plus C2 squared. And here is going to be just the sine of alpha plus beta t. I'm going to write first the beta t. So it's going to be beta t plus phi. And okay, so what has happened, engineers, is that instead of having the cosine and sine 2, here we end with a single one. So from here, this one is the amplitude. So the amplitude A is just the square root of C1 squared plus C2 squared. So okay, so you get your first formula of the amplitude. So we got this one. Okay, now the angle phase. The angle phase is actually this phase, this angle here. Okay, so from where we calculate this phi? From here. The phi is going to be if you clear the tangent over the phi, sorry, is going to be the tangent inverse of C1 over C2. And there you go. You got your second formula, this one, angle phase. This one, angle phase. Now, the period. Okay, the period is actually, we could actually calculate the period from the beginning, because the period for the sine and the cosine is actually the same. Is this beta. Beta is actually the angular period. So beta is the angular period, is 2 pi the frequency. Alright? So, and the frequency is 2 pi 1 over the period, equal to the beta. So the period is just 2 pi over beta. And there you go. This is in seconds. This will be the period, the time to complete a single cycle. Okay, so you got your 3 formulas that you will need to use for actually 4 formulas. This is the main one. Okay, this, and this. Now, you will apply these formulas only for free damping problems. All right. So if you happen to have an exponential here, then you don't have to do this. All right. Okay. Next video, we are going to cover one example. See you.